Once again, we're going to start looking at transformations. I know that the very beginning of the year, we had a project, and I told you guys, use any language you know, use math if you can. Like turning, I came and I said later on we're going to call it rotation. Flipping, I said translation, reflection. And pushing over, like sliding things over, I said we're going to call that translation. And as a matter of fact, we mentioned things about making things bigger and smaller, call that dilation. That's what all of that's transformation. So we're going to be learning transformation. But today we're going to be looking at translation only. The one thing in mathematics is that the names, many movies grab the names from math, or actually websites as well. They grab math names and then they use it. Like you guys have heard the word Google, it comes from the number Google names, which is the 1 with 1,000 zeros. Right? And then they grabbed it and then like, oh, we're going to make a website with a name similar to that. If you don't believe me, go to Google and Google why is Google called Google. And then you guys will see that it comes after Google. But transformations, you guys have probably seen a movie similar to that. It was a famous movie. It was pretty famous. They call it Transformers. So Transformers, that's a from transformation. Alright, now let's talk about, alright, let's start moving into transformation. So let's copy this thing off first. JC. So looking at our beginning, pre-image. Right, we're going to have what we call pre-image and we're going to have image. We have both. Pre-image is the image we start with. So what we start with is we're going to call pre-image. If I don't use the pre and just say image, is what we have after a transformation. And a transformation, like I said, is reflection, rotation, all of those. You talk to me so you're. Alright, so pre-image is what we start with. After the transformation, that's what we're going to call image. So make sure you guys understand the difference between those two. Don't think that image is the beginning. Image is after the transformation. The beginning would be pre-image. As an example, right? Don't copy this example. I'm just going to come over and show you guys. As an example, I start with a pre-image. Right? It looks like a triangle. But this is my pre-image. So I'm just going to go in translation. I know translation, you just grab it and move it. So my translation will look like that. Right? Now that's my image. I start with a pre-image and I finish with an image. The figure should not change. Should look exactly. This should be congruent. Should look exactly the same thing. All I did is that I moved it. That's all it is. Right? Sometimes we might turn it, we might reflect it, we might dilate it, make it bigger or smaller. But the image should look, pre-image and image should look the same. Dilation is the only one that changes because it makes bigger or smaller. But it should look the same. Now, the way we name the pre-image, so let's write this thing down. The way we name the pre-image is by listing the letters in clockwise or counterclockwise order. For example, B, C, D, E, F. I never told you guys which point to start at. Pick a starting point and then go either clockwise or counterclockwise order. Right? An example came in and said BC, look at my image, B, C, D, E, F. So we could have gone B, F, E, D, C. I go one way, but go in order. Clockwise or counterclockwise order. The way we name the pre-image is by listing the letters in clockwise or counterclockwise order. Once again, for example, B, C, D, E, F. And my pre-image, I could have called it, if I wanted to, I could have started at the E and then go any direction. I could have called it E, F, B, C. Or, starting at the E, I could have called it E, B, C, B, F. Right, Just start at one point and then go in order. What I'm saying on the first paragraph is don't just list the letters in any order you want. Don't come and call this B, E, C, F, D. Like, don't be jumping back and forth. Go in order. Go through the sentence. It doesn't matter if you go counterclockwise or you go clockwise. Then, the name, the way we name an image, remember the one after, the way we name an image is by adding an apostrophe to each letter. See, the little apostrophe looks like a little comma, but it's a little high. And we call it prime. When we add the apostrophe, we call that prime. For example, my figure here is B prime, C prime, D prime, E prime, F prime. The little apostrophe means we call it prime. So the way we name an image is by adding an apostrophe to each letter, and we call it prime. For example, B prime, C prime, D prime, E prime, F prime. Remember, each apostrophe, once again, always reading it with a little prime. And we draw it. Yeah, do me a favor, draw those here. And then you guys remember from the movie Transformers, there was something about prime, right? They grabbed that name and they included it in one of the characters. But once again, if it's a letter by itself, that's the pre-image. If it's a letter with a little apostrophe, which we call prime, that's the image. So pre-image and image. For the screen, here, I'll be using color. Right? Some of them will be blue, some of them will be red, black. But I can use color on the screen so we can easily see it. But on the Word, my printer only prints black and white, so all your papers are going to be black and white. Right? On the screen I can use color, but on your papers I cannot. And you guys will be able to tell which one was the pre-image, which one is the image, because of the writing. Right? The one that is letters only, that was the pre-image. The one with apostrophes, that's the image. So these right here? Yeah. The two there? Two images. So once again, once you guys see it on paper, the one is letters only, that's the pre-image. The one with the apostrophe, which we call prime, that's after the transformation. You'll be able to tell which one is which. Anybody still writing this? Okay. I'll wait. Here we go. Which one's called by this thing? Yeah, Optimus Prime, but we don't have to. Yeah, I'm getting a copy of it. But yeah, just my focus in this one is learn how to read them and learn how to write them. Right? For us to call one of them, start at any point, but go or counterclockwise or counterclockwise. Don't be jumping back and forth. Go in order. That's my focus. Anybody still writing this? No. Oh, you don't? Okay, I'll wait. So we have many transformations. There's 4, but today we're only looking at translation. This week only, translation. This one's going to take us about 3 weeks to look at all the transformations. Now, let's copy translation. Right now it sounds like mumbo jumbo, but I'll explain it a little bit more. Translation is a term used in geometry to describe a function that moves an object a certain distance. Translation by a vector AB, we write x, y, little arrow, x plus a, y plus b. Sometimes we describe it as a units right and b units up. Passing your worksheet while you guys are copying it down. translation is a term used in geometry to describe a function that moves an object a certain distance. Translation by a vector a to b, we write x, y, arrow, x plus a, y plus b. Sometimes we also describe it as a units right and b units up. Once again, it sounds like mumbo jumbo right now, but once you guys have a paper, I'll explain it. Oh, we're going to open it. Was he doing this? Did you do this? Oh, I didn't even know. Alright, so translation, it says we move it a certain distance. Okay, we move a certain distance. But keep in mind that certain distance, I never said which way. Alright, we could go up, I could have an image, I move it up, I can move it down, I can move it right, I can move it left, or I could even move it in the diagonal way. Right, that's what translation is. As an example, you guys see here, I have a right triangle, and I moved it diagonal. Right, I just dragged it. That's what translation is. This case, I moved it a few spaces to the left, and then a few spaces down. Looking at my other example here, starting with the red, I moved it a few spaces to the right and then a few spaces down. So that's what translation does. We move it in a certain distance. Something I never said which way, which direction. Now the translation by a vector AB, right? I introduced you guys to the vectors back in midpoint and endpoints. So a vector is how much it can move. Like that's what it tells us. So if I move it a spaces to the right, that's why we also describe it as a spaces to the right. And then if I move it up, if I was to move it up, then I would say b spaces up. Or we use this notation, like with the one with the arrow. If I'm moving it to the right, I go x plus whatever. If I'm moving it to the left, I go x minus whatever. Right? My x tells me right or left. Plus means I moved it to the right. Minus means I moved it to the left. My y tells me up or down. Plus I moved it up. Minus I moved it down. So now looking at this, my first example, the one with the triangle, for us to know how much we moved it, follow any point. It doesn't matter which one, because they all move the same distance. So I'm going to choose my bottom left corner, right, that point. And I want it to finish at the bottom left corner on the blue. So if I look at this, I go 1, 2, 3, 4 spaces to the left. So if I was to write this, 4 spaces to the left on the x, I will go x minus 4. That's 4 spaces to the left. Now it's going down 1, 2, 3, 4 spaces. So I will also call it y minus 4. Once again, I said xy becomes x minus 4, y minus 4. Remember, the x minus 4 meant I moved it 4 spaces to the left. And then y minus 4 because I moved it 4 down. We understand that? Good. Let's see if we really understand it. I'm going to start with the one with the rectangle. I notice I'm going to follow a point. I notice that I go 1, 2, 3 to the right and 2 down. So how would I mark this? 3 to the right and 2 down. Okay. X plus 3, y minus 2. Exactly. X plus 3, y minus 2. Right? This is basically what I'm saying. 3 to the right and 2 down. And how did we find out? Follow any point. Right? They all move the same, so follow any point. Right, now that we have this, let's take a look at our worksheet. Right, we're going to continue transformations later, but let me close this here. Let's take a look at the worksheet. Sometimes I will write it down like this. So first it says graph the image of the figure using the transformation given. Translation, 1 unit right and 1 unit up. And it asks me to graph it. So I want to look at my picture. I'm going to look at my corners. There's 3 of them. Move every corner 1 unit to the right and 1 up. So I notice my T, which is the bottom my t prime will be there, as I move it one to the right, one up. My v, let me move it one space up, right, one space up. So I'm going to call that d prime. Don't forget the little apostrophe. And then my u, one to the right, one up. I'm going to call that u prime. So see how I translated each point. Now for us to translate the triangle, just connect the points. And that. So it looks like the triangle, we moved it one space to the right and one up. Right? We did it to each of the vertices. Alright, so you guys have what? About 3 questions where I give it to you guys in words. But then, let me take a look at question number 4. Question number 4, I'm giving it to you guys in this notation. The x plus 3 represents what? 3 to the right. The y by itself means basically y plus 0. How many up? 0. So technically, we're just moving 3 to the right. And that's it, right? Just 3 to the right. So I want to grab, there's my e. So that's my e prime. There's my f. Move it 3 to the right. There's my f prime. There's my g prime. And then there's my d prime. And then just connect your points. And it looks like we grabbed the pre-image and we moved it 3 units to the right. And on the back, question 7 and 8, I'm using vectors. I meant to write it as arrows, but my program wrote it as a parenthesis. Right, so looking at number 7, right, it says 4 to the right, 5 up. And I know it's to the right because it's positive. So move it 4 spaces to the right, 5 up. So 7 and 8, you're still grabbing them. So that's not that bad. Any questions up until 8? No? On 8? Alright, let's take a look at number 8. Okay. We're looking at 8. It says 4 to the right, and don't move up, right? So just move everything 4 to the right. There's my S prime, there's my R prime, and then there's my T prime. Right? Just 4 to the right and 0 up. And obviously just connect the dots, and then you're done. You're good enough? Alright, now let's take a look at number 9. Now we're looking at numbers only. I'm giving you guys the coordinates. And I'm asking you guys to write a rule to describe each transformation. To begin with, it's a translation. So do me a favor and write translation. For today, since we're looking at translations only, all of these will be translations. But let's get used to writing the word translation, because once I get all the transformations, then we need to know which one it was. Like, was it a reflection, was it rotation, was it dilation? Like today they're all translations, true, but we need to get used to it. So let's write translation. And I'm going to write x, y becomes, so what are we doing to the x? How many are we either adding or subtracting to each x? Subtracting 2. Alright, so we're going to write x minus, right, and the way we figure it out, since we know it happens to all the x's, just pick any x that you want, and then you want to know what did they do to negative 2 to make it negative 4. Okay. Then what are they doing to the y's? Pick any y you want. Adding 2. Since we can pick any y that we want, I would have picked that. What do they do to 0 to make it 2? Add 2. Right, if you notice, it happens the same with every y. So pick any x and pick any y when it is translation. Let me do another example. That's it for that one, right? Just the rule. So for number 10, we have to write translation because it is a translation. And then we're going to say xy becomes, what are they doing to the x? Adding 1. So we're going to go x plus 1. What are they doing to the y? Subtracting 1. So we're going to go y minus 1. Remember when I said what are they doing to the x and to the y? If you look at d to d prime, what do they do to 1 to make it 2? And we say add 1. What do they do to 0 to make it negative 1? And we say subtract 1. And if you notice, that's the same thing in every point. Alright. So then, you guys have what? Up until 12 are the same thing. So let me move into question number 13. Now here, I'm asking you guys, find the coordinates of the vertices of each figure after the given transformation. So I'm giving you guys 4 points, the points N, M, L, K, and I'm giving you guys a rule for the translation. I need the points after the transformation. So I need the primes. What I mean with that is, I need N prime to begin with. I know I have to subtract 3 from the x and add 1 to the y. So what values do we get for N prime? What is it? Negative 4, 0. Good. All right, subtract 3 from the x and add 1 to the y for the N prime. Now, M prime, what values do we get for M prime? Negative 3, 4. All right, subtract 3 from the x, add 1 to the y. What values do we get for L prime? 1, 1. And lastly, K prime, what do we get? Negative 1, negative 2. Okay, that's all I'm asking for those. Any questions? All right, any questions? Expecting transformations, all of them, to get a little confusing. So translation will start this week. This week we're only looking at translation. We saw quadrados yesterday. We're looking at translations today. We'll review more translations for the rest of the week. Next week we move into more transformation. But this week is translation only. Like I said, I want to go a little by little. Once again, any questions? Yeah? All right, make sure you guys finish your work.